Hey kids, we are still solving linear systems, but this time we're going to use combinations. It's just another way to accomplish the same thing that we have been doing in the previous two sections. Before we dive in, this won't be the most perfect lesson in the world. It's just the high points, get people going at home. Different math teacher might do it differently, and that is totally fine. So this objective then is to use combinations to solve the system of linear equations. So for my class, for this lesson, I'd like for you to use the combinations, but from 7-4 on, you can use whichever one you would like. I'd just like for you to give this one a fair shot before you just decide. Okay, so this set of notes is set up just like 7-2. It's a very similar process. And so it was done that on purpose so that you can hold the notes, side by side to see how similar they are, and also so you can see the subtle differences between the two. Also, I will try to color code for you so you can see the different steps. And also, this whole front page will be one example, and then we'll blast through a couple other examples on the back. Another thing to note, we are going to kind of start easy on the front and then go moderate and then more difficult on the back. So it's kind of scaffolded that way too. All right, enough preface. So this is a 6-step process. The first step is to arrange the equations so that like terms happen in columns. So that means that the x's line up with the x's, the y's line up with the y's, the equals line up with the equals, and the constants line up with the constants. So it's not like I have an x here and a y, or a y here and an x here, and it's flip-flopped. I recommend, you can do whatever you want, but I recommend that you do the x's and y on one side, equals, and then your constant on the other side. In my experience, it works better, but you can do whatever you would like. Okay. All right, step number 2 is to multiply one or both of these equations so that one of the coefficients are opposites. So this one's already set up for us, so we're not actually going to multiply. But I want to show you what we're going for here. So here we have a positive 3 and a negative 3. So we're looking for opposites, not positive and positive. It must be a positive and a negative, because what we are going to do in our next step is going to blow your mind. We are going to actually add these two equations up together. And the reason for that, and this makes the opposite coefficients make sense. You can't solve an equation if there's two different variables, but if these two are eliminated, a positive and negative y cancel out. Now we're only dealing with the x's, and so we can solve for the x's. Okay. And when you can solve for just one variable, then we can do the same familiar step 4. Like the previous method, substitute that value from step 3 into one of the original equations. I suggest original just because they are more accurate. When you do so, make sure you're subbing in for the correct variable, and also show your work. Don't skip steps. Write what you're substituting in parentheses, and solve out for the other variable. Okay. It is possible to divide 0 into parts. Y is 0. Okay. And then step number 5 is to combine the x and y values into one coordinate. That's the solution. X comes first. So 4 comes first, y comes next. And because there are so many steps, there are also so many opportunities to make a simple mathematical mistake. Oftentimes students know the process very well, but they make a very simple, silly mistake on the way. And then unfortunately they get the wrong solution. So what you'll do is substitute 4 in for the x's, 0 in for the y's, and this coordinate should satisfy both, not just one. If this lies on one equation, that means that this point lies on one equation. But to satisfy both of them, it needs to be the point where the two lines cross. Okay, so 4x's would be 16, and 0 is 16, that works. 2x's would be 8, yep, equals 8. You can also use your calculator for this if you're in my class. Of course, I showed you how to do that. Yeah, okay. That was an easier one. Let's step it up a little bit. So this one is going to be more moderate. I'm going to try to straighten out my camera. Okay. Also going to zoom in now so you can focus a little bit better. All right, here we go. I'm going to try to keep this other question off the page so it's not a distraction. Okay, so before we jump in, feel free to go a step ahead, see if you can do any of this independently. Any independent thinking that you can do is an advantage. It's good for you. And then of course I'll walk you through. Okay. All right, so if we refer to the front, the first step is to arrange the equation so that the like variables are lined up. And they are, again, I like the x and y on the left equals and then the constant. You do you if you don't like that. All right, then we're going to multiply one or both of the equations so that we have opposing opposites. So this is where lowest common denominator in 6th grade comes in. This is why you learn this. So here you'll see that I have y's, right? I can't multiply 2 by any whole number to get 5 evenly. Can't multiply 3 by any whole number to get 4 evenly. So that means I'm going to have to either multiply by the opposite, so 3 times 4 and 4 times 3 to get 12s, right? Or I'd have to do this top row by 2 or the bottom row by 5 to get opposing 10s. But I'm going to choose the x's actually because I already have a positive and negative combination here. So when I multiply this top row by 4 and the bottom row by 3, I'll actually have a positive 12 and a negative 12, which will cancel out so I can solve for y's. Now I could do the y's. I could multiply the top by 2 and the bottom by 5, but one of them would have to be negative so that I can cancel them out. So that's why I choose the ones that are already positive and negatives. So lowest common multiple of 3 and 4 is 12. We'll get these up to 12 by multiplying the whole top row. It kind of reminds me of the distributive property. By 4. And the whole bottom row by 3. Don't forget the constant at the end. That's a very common problem that I see. Okay. So now we have the positive 12 and the negative 12. So this is where the combinations come into play because we are looking for a combination of variables that will cancel each other out. Positive 12 and negative 12 are gone. 6 and 2 y's are 8 y's. Okay. And you know what? I'm going to stop there. I made a mistake. This is why you check your work. 4 times 5 is not 2. 4 times 5 is 20. And then so 20 plus 6 is not 8. It's 26. Okay. Keep going. Divide by 26. Divide by 26. Don't just freak out if you see that something's going to work out to be a fraction. It's okay. I try to spare you from fractions so that we can focus on what we're learning and not manipulating fractions. Good or bad, that's what we do. But we do need to do, fractions and decimals occasionally so that you can see, you can work with them just fine. So 39 over 26, 26 goes down 39 once, with 13 left over. 13 over 26 is 1/2. So y is 1/2. Okay, so now that I know what y is, I can substitute that in for either of the y's here. It doesn't matter. I'm just going to pick this bottom one because I can get to it. 2 1/2 equals 5. Negative 4x and 3 is 5. Negative 4x is 2. X is negative 1/2. Great. Bring your coordinate together. Make sure the x comes first. The y comes second. So this would be the intersection point of these two lines. And just to make the point, you could write both of these in slope-intercept form and then graph them, and they would intersect here. You could, if you wanted to, solve for one of these variables and use the substitution method. I wouldn't advise it because you're going to get a lot of crazy fractions that you're going to have to deal with. But that's completely up to you. Okay. All right, now we're going to solve it. Sub it in. I'm having a hard time talking. All right, I'm going to have to write this one out. Let's see, 3 negative 1/2 would be negative 1/2. 5 of those would be, 3, 6, 7.5. Is that 6? Yep. Okay. Negative 4, negative half would be positive 2. Plus 2y's would be 3. And that's 5. Okay, that works. So it satisfies both equations. So this is our answer. Kapow. Good job. All right. Take a moment. Let it sit in. Write your notes. Make sure you understand before we move on to the next one. Okay. You got this. Again, feel free to pause and go it on your own as much as you can. Try that, pardon me, independent thinking. And then I'll kind of talk you through the process. Okay, here we go. Step 1 is to arrange your equations so that the x's line up with the x's, y's and y's, equals and equals, and that's not the case here. Boo. So what we can do is, now that we really know how to rewrite equations in really any order we want, we can apply that skill to manipulate the equation so that it follows the same order as the other equation. Doesn't matter which one you choose, I just like to have my x and y over to the left. Now, some people can just look at these two and work with them with a space in between. I'm not one of those people, so I recommend that if you rewrite this equation, draw an arrow and put them together. Some of you kids are more spatial than I am, and I'm jealous. Okay, so now step 2 is to multiply one or both equations so that we have opposite variables. You could, if you wanted to, multiply the top by 3 and the bottom by 5 to get 15s, but there's something easier that you can do. I already have 2's. Now 2 and 2 is 4, so that's not going to work for me. But I can multiply a whole equation by -1, and they will cancel each other out. And it doesn't matter which one I do. So if I multiply this whole equation by -1, this would become negative, this would become negative, and that would become negative. Okay. So when I do that, I'm creating a combination of variables that cancel out. So I'm taking y's out of the equation, so to say, and literally. So now I can just focus on the x's. And then I'll use my answer, like what we've been doing, to then find the y. So if x is 2, I'm going to use this guy again. I love seeing you guys' work for this. It really looks like a roadmap. Stuff going everywhere. 3 instead of x, I'll do 2 because that's what x is worth. Be sure you're subbing in for the right variable. Use parentheses. Don't skip steps. Solve for that y. Yep, I'm off the page. Sorry, kids. So y is 1. And so, bring that together. It's very satisfying to see all this work, man. Makes me feel smart. So I got 2 and 1. I could have made any number of mistakes there. Who knows where something could have gone wrong. So it's crucial that we check our work. And so 3x's, 3 2's is 6, plus 2 is 8, yep, that works, is 2, 12 minus 10, yep, that works, okay. If you struggle to do that mentally, feel free to write it out, or again, you can use your calculator to check your work as well, okay. All right, this is a tough thing, but it gets easier the more you practice at it. If you need some help or a set of eyes to look at a problem that's just not working out, feel free to snap a picture of it and email it to me and say, help. I can look at that and help you. Of course, I can help you at school too, but that's not helpful to you on a Saturday when you're trying to get your homework done. Yeah, so I hope that was helpful to you. And I'll see you back in class. Thanks. Bye.